Hi again, everybody from the backyard. I wanted to walk through some more of the math on the problem we started yesterday, a static friction problem. So the thing about static friction is that it essentially doesn't exist until a force trying to oppose it comes into play. So in other words, when you have an object sitting on an incline, if it is not moving, that static friction is going to be just enough force to oppose your downhill gravitational force. So I've set this up to show uphill we've got friction, and then downhill, equal and opposite, we've got our gravitational force. Since our object is not levitating off of the surface, we've got a normal force, and it is exactly canceling out the component of gravity that is perpendicular to the plane. So we have a Newton's first law situation, both horizontally along the plank and vertically perpendicular to it. So those forces are going to be equal and opposite. So here we've got our normal force equaling mass gravity times the cosine of theta, because that's the adjacent side of this triangle. We have our frictional force equal and opposite to mg sine of theta, because that's the opposite side on this triangle. And this triangle, remember, has a hypotenuse that's equal to the weight of that object resting on the plank, because gravity always points straight down. So in order to solve for our maximum frictional force, you're going to need to levitate your plank until the object breaks free and just starts to slide. At that point, you know that your gravitational force was enough to overcome your maximum static frictional force. So maximum static friction is always that coefficient that tells you how sticky those two surfaces are times the normal force. If you substitute this back into that equation, you can either solve based on the angle for what this coefficient of static friction is, or conversely, if you know this, you can figure out what angle you can raise your plank up to get that object to just start to slide. Now, I'm trying to keep these videos as short as possible because I know everybody's probably under a little stress right now, to put it mildly, and I don't want to burn out your attention span. But I was thinking tomorrow, as soon as I finish my morning chores, we can go ahead and put some numbers in. I also was going to bring back our trusty plank and make sure everybody knows how to measure an angle by using proportionalities. Because remember, this angle here doesn't actually depend on the length of the hypotenuse or on the length of each of the sides. It depends on that ratio between those two things. So if I can get an assistant tomorrow to help me with a piece of string, and I'm going to go ahead and put several different objects on this plank and try to measure some angles to determine the coefficients of static friction for different objects. So after a couple of these short lectures, we're going to move on to working some problems out with dynamics. In other words, when the objects are sliding. The only way that a friction problem is going to change is if your object is sliding downhill, this equation no longer is going to equal 0. This equation is going to equal ma. And if that object is sliding at a constant velocity, that acceleration is still 0, and you're still under the first law. But as soon as it's starting to pick up speed as it slides down the hill, first of all, you're no longer under static friction, you're under kinetic friction. So that number should be slightly lower than your static friction force. And if your velocity down the hill is changing, you're going to have some acceleration right there. So we'll play around with this a little bit more tomorrow. I hope everybody is doing okay, and I hope you all have a great weekend. Remember, I'm here. My office hours are still the same. I'm currently trying to figure out how to get my phone forwarded, and I will keep you updated as often as I can.